Hi, this is Ranjan. For this technical assessment, I build a visual pipeline builder using React and React Flow. For the front-end gestion, for the state management, Tailwind CSS for styling and fast API for backend validation. The main goal of this project was to create a scalable node abstraction system and validate pipeline correctness using directed acycle graph detection. So here users can drag and drop different node type such as input LLM and output onto the canvas, right? Users can visually connect this node, construct the workflow. Uh, for example, I can connect input to LLM and once again we can uh, connect LLM to output finally. So by this, we are just creating a workflow from the input to LLM and LLM to output. It is created a workflow. So after this, we can check the validation of this workflow, like to click the submit button. It will show the our validations is correct or not, like, and we can see also the countings, numbers of node and edges connected. So this is basically after this. Okay, so let's come to other code. uh, in this, instead of duplicating layout, I handle logic across the node type. I created a reusable base node. This is basically our reusable node base. So the the base node component centralizes shared styling input, output handle, rendering and layout structure. Each specific node simplified define its input output configurations and any custom content. This will make architecture modular and scalable, easy to extend. For example, we can see that like when we open the math node, we will see the only we have only input output configurations here in the this node. There is no any styling and other requirements for this. So actually, this code styling and other requirements were centralized to the base node in this. So basically, this is base node for the centralized system for the all nodes. Because of this, we can make multiple nodes easily and extend our program as well. Okay, to demonstrate this flexibility, I have created additional 5 custom nodes that were implemented using the same abstraction, like merge node, note node, output node, text node as well. The text logic is also enhanced functionality, like we can see the first area in the text node. So basically, this is our text node. So for the text area, automatically resize uh, as the user type, like when we type multiple things, like, and it will automatically resize the text area. Basically, it improve the visibility and user experiences. For example, like I typed hello name and hello name, hello name and email. This node automatically detect the valid JavaScript variable name and generate corresponding input handle on the left side. This is input handle on left side as well. This allow dynamic parameterization within the workflow. Uh, so okay, we will go through the backend as well. So this is our backend code as well. The for backend integration, when the submit button clicked, the front end send. Basically, then submit button clicked on the front end, and the front end send the current node and is to the fast API. Okay, here we receive the details from the front end, and the backend calculate the total numbers of basically backend here calculate the total numbers of nodes and edges and verify whether the graph form a directed acyclic graph or uh, if the pipeline has no cycle, the backend return is tag as a true, right? If I intentionally create cycle by connecting the output nodes, before I said like created a cycle. So in that case, output node back to the input node and submit again. The backend detect cycle and return detect false. This ensures the only structural valid workflow are accepted and prevent infinite execution loop, right? Overall, this implementation focus on clean UI and architectures, reusable uh, reusable codes, components, uh, abstractions, dynamic UI behaviors, and structural validations of the directed workflow. Thank you.